According to Newton's second law of motion, the rate of change of linear momentum of a body is directly proportional to the external force applied on the body, and that external force is applied, it is analyzed according to in the direction of that external force applied, right? So after analyzing that statement and after many mathematical calculations, we came up with a result of F equals ma. This F equals ma was given in Newton's second law of motion. This F equals ma was deducted through Newton's second law of motion. Now, according to this equation, the force applied on that body is equal to the mass of that object or mass of the body times the acceleration, about what amount of acceleration that body or that object moved, right? So if we put up the result of acceleration, what is the result of acceleration? I mean to say, what is acceleration? Well, acceleration is rate of change of velocity, or we can also say that acceleration is the change in the velocity with respect to time, and the change in with the velocity with respect to time is v minus u upon t. So we're going to put up this value here, and we came up with one more result of Newton's second law of motion, and these two results are very important for the numerical purpose, for the questions purpose, okay? So we came up with these two results with Newton's second law of motion. So in this video, we will discuss about some basic applications of Newton's second law of motion which we get to see in our daily life. Hello everyone, this is Devinder Kaur and you all are welcome to my YouTube channel, The Enlightened Room. So there are some day-to-day observations through which we can analyze these two results, these two equations, if we see the things around us clearly, okay, and we think about them. So let us take the example of cricket. I know most of you like cricket, right? So in the cricket, let's assume you are watching a cricket match or you are playing with your friends. So if you are watching cricket or playing cricket, so suppose there's a player who is trying to catch a ball, right? So what that player will do when the ball is near his hands, you can see it through the picture here. When the ball is near its hands, to catch that fast cricket ball, the player will pull the hands backwards to prevent injury to his hands. Well, he will catch the ball, and just after catching he will pull his hands backward. Now by doing so, the player increases the time during which high velocity of cricket ball reduces to 0. So thus all the acceleration of the ball, that means A equals v minus u upon t, is decreased, and therefore the impact of catching the fast ball which is F equals ma is reduced, and thus the player has to apply a smaller force against the ball in order to stop it. So the ball in turn exerts a smaller force on his hands and the hands are not injured. So what would happen if the ball were to be stopped suddenly? That means the player will not pull his hands backwards and he just not change the position of his hands. What will happen? The high velocity of the ball would be reduced to 0 in a very short interval of time. Therefore, the rate of change of linear momentum of the ball would be large, and therefore a large force would have to be applied for holding the catch, and the hands of the the hands of the player would be hurt. Now let's take the example of games again. In a high jump, a player is made to fall on the cushion bed or on the sand bed to avoid the injury. Now why so? By falling on the cushion bed or on a sand bed, it will increase the time during which the high velocity of the athlete or high velocity of the player would be reduced to 0. This would decrease the rate of change of momentum of the athlete and hence the force on the athlete. The injury to the athlete is thus avoided. Now one more basic application of Newton's second law of motion is use of seat belts in car. All the cars these days are provided with seat belts for the passengers. Now this is for the safety for the passengers, and these are also known as safety belts. Now the purpose of these safety belts or seat belts is to prevent the injuries to the passengers in case of any accident or in case of sudden application of brakes. So in both the cases, that means in case of accident or in case of sudden application of brakes, a large momentum of the car reduces to zero in a very short interval of time, resulting in the development of a large force causing injuries. So that stretchable safety belt worn by the passengers of the car would exert a force on their body and would try to make the forward motion very slower, okay, much slower. So the time taken by the passengers to fall forward increases, therefore the rate of change of momentum of the passengers is also reduced, hence the stopping force acting on the passengers is reduced. Now they may not get injuries at all, or they may get away with minor injuries. Now apart from these basic applications of Newton's second law of motion, there is one more thing I want to tell you, that Newton's first law of motion is a special case of Newton's second law of motion. That means you can also say that with the help of Newton's second law of motion, one can deduce Newton's first law of motion. Now how so? So we have this equation. F equals m times v minus u upon t. Now let us take t here. I am going to write it here. F times t equals m times v minus u. Now let us suppose there is a body on which a force is not applied. That means there is a book on which a force is not applied. So if the force is not applied, that means that force is zero. If it is not applied, it is not existing there. There is no external force acting on the body. That means let us assume that F is 0. Now if this F is 0, 0 times t would be 0. So we would say that 0 equals m times v minus u. Now one thing you need to remember is that m is a non-zero quantity. M is never equals to 0. It is a non-zero quantity, so it cannot be equating with 0. So it cannot be placed here. So we are going to remove this m here, and we will be left with v minus u equals 0. And hence it will be v equals u. So one more thing I want to tell you, that if you all are not getting this m is not equal to 0, this term, that means actually it is a mathematical term which is used in higher mathematics. If you are not getting this, I have some other way too. So that other way is I am going to solve it. This part I am going to solving again here with some other method. So I am going to take m here. It is 0 equals m v minus u, right? So we can also write it as 0 equals to m v minus mu. Okay, by multiplying m with v and u. You can also write it here like this. So mv equals to mu, and this m and m would be cancelled here. Both are on the equation side, and these can be cancelled. So again we will be left with v equals u. Now this v equals u. What does this v equals u mean? It means the body will continue to move with the same uniform velocity u throughout the time t when no external force is applied on the body. Further, if u is equals to 0, then v will also be 0. It means that the body is initially at rest, it will continue to be at rest, and when no external force is applied on the body, it will remain at rest. So this is what this is, Newton's first law of motion. So today we discussed about some basic applications of Newton's second law of motion and how we can deduce Newton's first law of motion through Newton's second law of motion. I hope you all understand my lecture, and I hope this lecture was useful to you. If it is useful, do like it, do share it with your friends, do share your views in the comment section, and also subscribe to my channel. Thank you so much.